Coming up on SpaceTime, more evidence of liquid water on the surface of modern-day Mars. A new study questions whether or not we've got the shape of the Milky Way galaxy all wrong. And construction continues on NASA's new Europa Clipper spacecraft bound for Jupiter. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
China says its Zhurong rover has found evidence of liquid water on dunes on the surface of modern-day Mars. A report in the journal Science Advances claims data from the rovers now provided key observational evidence that liquid water does exist at low latitudes on the modern-day Martian surface. Previous studies have already proven large amounts of liquid water existed on early Mars, but with the loss of most of the early Martian atmosphere, the red planet has slowly turned from a warm, wet world capable of hosting life to the barren, freeze-dried desert it is today. The planet's very low air pressure, just 1/99th that of atmospheric pressure at sea level on Earth, means liquid water, essential for life as we know it, simply can't exist for long on the Martian surface, and usually sublimates directly from solid ice into a vapor. Nonetheless, NASA found droplets of liquid water on Phoenix's robotic arm, proving that at least salty liquid water can appear during summertime at high latitudes on modern-day Mars. Until now, however, no evidence has shown the presence of liquid water at low latitudes on Mars. The Zhurong rover, which is part of China's Tianwen-1 Mars exploration mission, successfully landed on the surface of the red planet on May 15th, 2021. The landing site was located at the southern edge of the vast Utopia Planitia plain in the Martian northern lowlands. Mission scientists used data obtained from the rover's navigation and terrain camera, as well as its multispectral camera and the Mars surface composition detector, to study the different scale surface features and mineral compositions of sand dunes in the landing area. They found some important morphological features on the surface of these dunes, including crusts, cracks, granulations, polygonal ridges, and a strip-like trace. And an analysis of the spectral data reveals that the dune's surface layer is rich in hydrated sulfates, hydrated silica, trivalent iron oxide minerals, especially ferrihydrite, and possibly chlorides. Scientists claim that according to the measured meteorological data obtained by Zhurong, these dune surface characteristics are caused by liquid saline water forming on the dune surface, most likely from melting frost or snow falling on salt-containing dune surfaces when cooling occurs. Specifically, salt in the dunes is causing frost and snow to melt at low temperatures, forming salty liquid water. When the saline water dries, the precipitated hydrated sulfides, opal, iron oxide, and other hydrated minerals cement sand particles of the dunes together, forming a sort of aggregate crust. And then that crust is eventually cracked by shrinkage. The authors say the later frost or snow melting process further forms polygonal ridges and a strip-like trace on the crust surface. The estimated age of the dunes is between 400,000 and 1.4 million years old, and the relationship among the three phases of water suggests that the transfer of water vapor from the polar ice sheet towards the equator probably led to repeated humid environments at low latitudes. This is SpaceTime. Still to come, a new study suggests we may have got the shape of our galaxy, the Milky Way, wrong. And construction continues on NASA's new Europa Clipper mission to the Jovian system. All that and more still to come on SpaceTime. A new study claims that scientists may have got the shape of our home galaxy, the Milky Way, all wrong. The research, reported in the Astrophysical Journal, claims that the Milky Way has just two primary spiral arms, not the four currently hypothesized. The new research is based on new long baseline interferometry measurements of some 200 key stars. And it's supported by data from the European Space Agency's Gaia Space Observatory, which has mapped the location of 24,000 giant OB blue stars, as well as nearly 1,000 open cluster stars. The authors say that for many years, astronomers have imaged the Milky Way galaxy as being a spiral shape with a central bulge and 4 primary spiral arms, as well as several smaller branching arms, including the Orion arm, upon which our solar system is located. However, the authors point out that observational evidence shows that other spiral galaxies usually have only 2 main arms, with the spirals then splitting into smaller arms. They say that based on their measurements, the most likely shape for the Milky Way would be a barred spiral, but with only 2 rather than 4 main arms that stretched outwards from the central bar. And they say other shorter arms are more irregular and distant and not directly connected to the main structure. This is SpaceTime. Still to come. Construction continues on NASA's Europa Clipper mission to the Jovian system, and later in the science report, we take a scary look at what's really inside your hot dog frankfurts. All that and more still to come on SpaceTime. Major construction works continuing on NASA's largest ever interplanetary spacecraft, the Europa Clipper, which will launch next year on a mission to study the Jovian ice moon Europa. Between now and its October 2024 launch date, thousands of hours of work will go into assembling and testing the spacecraft to ensure that it'll survive its 6-year, 2.6 billion kilometre journey to the Jovian system. Europa Clipper will reach the gas giant and its system of 95 known moons in 2030. Once there, the probe will undertake a series of scientific observations using a sophisticated array of research payloads. The spacecraft will focus its attentions on the ocean world of Europa, which scientists believe probably contains more water than all the Earth's oceans combined, but hidden under a thick, crusty ice shell. The 6,065-kilogram probe will fly by the Galilean moon about 50 times while orbiting Jupiter. The spacecraft can't actually orbit Europa directly. That's because doing so would bring Europa Clipper too close to the gas giant's brutal radiation belts. On each flyby, a suite of scientific instruments will gather data on the depth of the subsurface ocean, the thickness of the ice crust, and potentially the characteristics of any geysers or plumes that might be venting subsurface water into space. The goal of this mission is to find out whether Europa has the potential to support life. The moon's subsurface liquid water ocean has been slowly stewing for over 4 billion years. The mission will launch aboard a Falcon Heavy rocket and undertake a series of gravity assists from Mars in February 2025 and then the Earth in December 2026 before finally arriving at Europa in April 2030. This report from NASA TV.
NASA's Europa Clipper will explore an icy moon of Jupiter to see if there are conditions that could support life. Let's head into the spacecraft assembly facility behind me to see how the mission is coming together. I'm Raquel Villanueva, here today with Jordan Evans and Trina Ray. Before we can head inside, there is one more step we need to take.
We have to gown up. We have to protect the spacecraft from us, all the particles that might fall off of us. So to cover our hair, we have to not wear makeup, no perfume. The Europa Clipper mission is a spacecraft that we're sending out of the Jupiter system. It's going to orbit Jupiter, but fly by the moon Europa. And it's a moon that is, we think, has an ocean underneath. And we want to investigate that.
We'll be in this room until we ship to the Kennedy Space Center for our launch campaign in the late spring of next year, 2024. During that time, it'll make a couple of trips out of this building for testing.
We have so many questions about Europa. We have an icy crust with an ocean underneath, and the water that's in that ocean has been sort of, churning and stewing for like 4 billion years. And so we've got a lot of questions to try to answer about the interior or about the geology or about the composition.
To answer those scientific questions, obviously we have to get to Europa first. So one of the key elements of the spacecraft design is being able to bolt the spacecraft onto the rocket. That'll give us the energy we need to get to Jupiter. And then once we're at Jupiter, being able to generate electric power and accommodate our very large solar panels and our very large high-gain antenna to send that science data back to Earth. And all of that has to be done with materials that are safe for the immense radiation environment at Europa. We bolt Europa Clipper to the Falcon Heavy rocket. Inside there are our propulsion tanks, some sensitive communications electronics where our large high-gain antenna mounts. There's some paper on the outside, and those are actually patterns for the sewing that's required on our thermal blankets. Thermal blankets with the right optical properties to maintain the temperatures of the vehicle, as well as provide protection from micrometeoroids.
Trina, can you kind of tell us more about the instruments?
We don't have all of our instruments on board yet, but what we do have are 3 of our cameras. We have cameras that operate in the visible. We have cameras that operate in the infrared, cameras that operate in the ultraviolet. Those all look at Europa at the same time, just in different wavelengths. But then we also have a thermal imager. So think of that as like the night vision goggles, right? So what you're looking for there is a thermal signature. So imagine you have this ocean and it's churning away, and it makes the ice right above it a little bit warm. And so the thermal imager will be able to tell you that.
And seeing the spacecraft up close, I just want to know, what does this mission mean to the both of you?
It represents the hundreds of thousands, the millions of hours of the dedicated engineers and technicians and scientists.
I treasure my job every day. I come to work and I'm like, we're going to do our part. We're going to answer these questions, but we're going to ask the next questions for the next generation to be inspired and to build their spacecraft and go.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Medical authorities are warning that the effectiveness of COVID-19 vaccines against the Omicron strain wanes rapidly over time. The findings, reported in the Journal of the American Medical Association, are based on a review of 40 studies. The estimated vaccine effectiveness against both laboratory-confirmed Omicron infection as well as symptomatic disease was less than 20% 6 months after the primary vaccination cycle. Boosters restored vaccine effectiveness to levels similar to after the primary doses, but 9 months later, booster effectiveness had nevertheless dropped to below 30%. The authors also found that the protection vaccines against Omicron last less long than against the Delta variant. On the bright side, the new results could be used to inform the design and timing of future vaccination programs. Almost 7 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization estimates the true death toll is likely to be over 16 million, with some 688 million confirmed cases globally. New research shows that the formation of ultrafine particles spewing out of jet engines is not confined to the combustion of kerosene alone. A report in the journal Communications, Earth and Environment warns that ultrafine chemical particles produced by jet engine synthetic aircraft lubrication oils are so small they penetrate deep into the lower layers of the respiratory tract, overcoming the air-blood barrier and causing inflammatory reactions in human tissue, including cardiovascular diseases. The findings by scientists at Frankfurt University indicate that these ultrafine particles are less than 100 millionths of a millimeter, that is 100 nanometers in size. And they're particularly prevalent in the smallest particle classes, which are just 10 to 18 nanometers in size. A new study has revealed the mysteries contained in your average hot dog frankfurter. And it seems, as well as the usual bits and pieces that you'd rather not know about, there is one huge surprise. A company which genetically tests food products called Clear Foods carried out the research, testing some 345 hot dogs and sausage samples from 75 different brands in order to see if the products matched what was described on their labels. And the results were absolutely fascinating. they found 100% of kosher products were clean and tested pork-free. However, it turns out that some 14.4% of other samples didn't contain what was advertised and included substitutions such as pork for chicken or turkey. Disturbingly, they also found 10% of vegetarian products also contain meat. Even more disturbing, 67% of vegetarian samples had hygiene issues. However, the most unappetizing discovery by ClearFood was that human DNA was found in 2% of all samples tested and in 66% of the vegetarian products. By the way, 2022 saw two important anniversaries in the art of science fiction. It's supposedly the birth year of George Jetson, and more importantly for this study, it's also the date in which the movie Soylent Green was set.
Listen to me. You gotta tell them Silent Green is people. We gotta stop them somehow.
They say art imitates life. Well, it seems life can also imitate art. To quote the immortal Dr. Sheldon Cooper,
I don't mean to be rude or discourteous. I'd just like to say that there's absolutely no scientific evidence to support clairvoyance of any kind. Which means, and again, no insult intended, that you're a fraud, your profession is a swindle, and your livelihood is dependent on the gullibility of stupid people. But again, no offense.
Well, there's one group of psychics that most people consider to be the worst of the bunch, those that volunteer their services to police and grieving families in high-profile murder cases. Tim Mendham from Australian Skeptics says these people have now been given a title: grief vampires.
Wherever there's a mysterious death, someone disappears, etc., you will find a psychic puts their head up and offers their very useful advice. Often unrequested, they're referred to as grief vampires, who will come in and glory in the fact that a family or something is in great distress, and they will come and say, I will help you.
It's the opposite of Colin Robinson, then.
Who's Colin Robinson?
You've never watched What We Do in the Shadows?
Only occasionally, yes.
Colin Robinson was the energy vampire. He would suck the energy out of you.
Oh, right, okay. Right, I'll take your word for that.
Basically by just talking to you about inane subjects non-stop. Sort of like what we do, I guess.
Yes. Do you know Eric Olthwaite?
I thought you were sneezing, sorry.
Eric Olthwaite is the most boring person in the city of some English country town. He's so boring that his family moved house and didn't tell him. It's a ripping yarn with Eric Idle.
All right, back to our story about psychics and crimes.
The people who pop up, the psychics who pop up to help people are described as grief vampires. In other words, they'll come and offer their help and they'll feed off you, often for their own reputations, etc. It may be money. It may just be that's the way they get their kicks. So whenever you have a mysterious disappearance, especially kids, they will pop up and either offer you advice, sorry, you're dead, or yes, she's out there somewhere and we will find her, but she's actually dead. It's very depressing. It's actually more than depressing. It makes you very angry, these people. So whenever there's someone missing, you'll get a psychic pop up. And there was a case of a woman who was missing in the UK, walking her dog beside a river and just suddenly disappearing. So there are all sorts of theories put up, all sorts of psychics came up with their ideas. And one of them, as a psychic, apparently found the body. Now, I'm not quite sure if he was claiming psychic powers due to the body, but he says, I was not asked by the police or the woman's family to become involved in the case, but he will get publicity out of it, obviously, as a psychic. And he was actually pleased that the police took him seriously. Well, all he had to do was come and say, I found a body. There's another case, Madeleine McCann disappearance. Which is probably one of the most famous childhood disappearances. And you wonder why this one case is such a high priority, such a high publicity, and such a longevity about it. But a Polish girl claimed to be Madeleine McCann, claiming she had the same sort of body markings and that sort of stuff.
But she won't allow herself to be DNA tested.
No, but some psychics have come forward and explained that one of them is helping her, go through all her traumas and things, and another one came up and said, no, she's not the real thing. But those psychics pop up. Now, the thing is, every psychic with their salt is going to say, I've helped the police solve cases. The police will say no psychic has ever helped us solve a case. They do occasionally talk to them. They rarely go out and consult them, but the psychic might phone them up and say, the body's in the lake. And that apparently is helping police solve the case, even if the body was not in a lake. So they will put themselves forward, they'll make suggestions, the police will say, thank you very much. And if the case is solved and this person happened to be by a bit of water, it might be a swimming pool, they will claim, see, I was accurate and I knew all along. But they're shonks. And then some of them, believe what they're doing is real. Some of them are out there just to get publicity. And it's very sad. It's very sad when they're picking on desperate people who need some sort of closure. And so these grief vampires pop up all the time and saying, I will help you, I'll help you. And of course, they publicise the fact that they supposedly help them when they never do. In fact, they probably make things worse, obviously.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.